Since the launch of the X1 Carbon, Bambu Lab's lineup has expanded rapidly, now offering solutions that cover a wide range of budgets and application needs. Even with the expansion, there were two common requests that I was still seeing just last year. These were a larger single-tooled 3D printer, which Bambu Lab addressed with the launch of the H2S, and the much bigger ask of a true tool-changing system. Well, on August 26th, we finally got our answer. Sort of. Bambu Lab released a teaser video along with a blog post showing off a hot-end swapping system called Vortek. Unlike a more traditional tool changer that swaps out the entire toolhead, this uses a rack system to grab and place hot ends during a print. A little over a month later, the system launched in the form of a new flagship printer from Bambu Lab, the H2C. Bambu Lab sent over one of these for testing shortly before launch, and over the past few months, I've had plenty of time to get hands-on experience and see what this machine actually offers. In this video, we'll dive into the H2C, go over its specs, what setup was like, how it's performed, and I'll give you my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. Like we typically do, let's run through specs. There is an absolute ton to cover, so I will try to be as thorough as possible. The Bambu Lab H2C is a fully enclosed Core XY 3D printer with a build volume of 330 by 320 by 325 millimeters. It has a glass front door and a removable glass top panel. The outside uses some large plastic textured panels, and on the inside the machine seems to be largely made up of aluminum, with injection molded pieces being used to connect a lot of the different components. For motion, the Y-axis uses beefy 12mm smooth rods and bearings, and the toolhead rides back and forth on the X-axis using a linear rail. The H2C uses 9mm belts. For the Z-axis, the bed rides up and down on 3 lead screws as well as 3 rods and bearings. The bed comes equipped with a magnetic flex plate system, and the stock surface that the printer ships with is dual-sided powder-coated PEI. There's a couple of alignment tabs at the back of the bed to help when putting the build plate back in, and at the very back side of the bed there is a whole array of different sensors and patterns used for the calibration process with this printer. At the very front underside of the bed is a light bar, and aside from it just looking really pretty, it actually does give you some information about print progress as well as just some different statuses. Thanks to VoxelPLA for sponsoring today's video. VoxelPLA Plus High Speed and VoxelPETG Plus High Speed are engineered for maximum reliability and toughness, while still being affordable. At $16.99 a spool, their pricing is extremely competitive. They even offer additional bulk discounting and free shipping in the US on orders of $75 or more. All their products are developed, produced, and tested in the USA. Voxel provides a complete filtration and anti-vibration solution for Bambu Lab P1 and X1 series and the H2 and P2 series printers. Check out the link in the description to find out more about their high-quality, affordable filaments and printer upgrades. Moving on to the toolhead, and there is a lot going on here. The front cover is just held in place with some clips, and if you squeeze near the top, you can pop it right off. Inside that front cover is a very low profile layer cooling fan, as well as another sort of LED light bar, which, similar to the bed one, looks pretty and also does give you some status information. With that front cover off, we can see a bit more of the toolhead. Starting at the bottom, we have 2 completely different hot ends. The one on the left is the exact same one that the H2D uses. It's held in place with a latch, and there is an internal mechanism that raises and lowers that toolhead when it's being used or not used during a print. Then on the right side, we have a Vortek hot end, which uses a completely different design. This uses inductive heating, has magnets on both sides for docking and grabbing, and has a PCB that stores and is used to read data such as hot end type, temperature, as well as the current filament loaded. The inductive heating side is completely wild, and I can get this thing from room temperature to 220 Celsius in right around 8 seconds. There are not one but two cameras inside this toolhead, with one being towards the front right side and the second one being at the very back bottom. These are used for calibration as well as checking for things like alignment with the Vortek hot end rack system. Above the hot ends is the direct drive extruder mechanism. I didn't take this apart, but it is using a PMSM servo. PMSM stands for Permanent Magnet Synchronous Motor. I could post a link for anyone interested in reading up on them, but in short, they are known for smooth, strong, and accurate rotation. The extruder has both a filament runout as well as a clog or jam detection, and as far as I can tell, the extruder is a single extruder that uses some kind of an internal rocking mechanism to basically choose between feeding to the left hot end or the right hot end. At the very top on either side of the toolhead, there are two filament cutting arms. The way the filament cutting is done on the H2C is identical to that of the H2D, but if you haven't seen it, it is a pretty clever solution. As the x-axis moves towards the back of the machine, it hits a lever that pops out two posts that are then used to depress either cutting arm. Then when the x-axis moves forward to print, it bumps into those arms, pushing them out of the way completely. Since these arms are able to pop in and out, it means that there is no lost build volume or no unnecessary use of space inside the machine. And also compared to something like the X1 Carbon that has to go to the front when it's cutting, this is closer to where it's going to be doing a swap, which means quicker swaps in general. On the left side of the printer is a large auxiliary fan that is used for additional part cooling. On the right side is the Vortek rack system. This holds up to 6 Vortek hot ends or 5 hot ends plus the one that is going to be loaded in your toolhead. I don't want to say this system is simple because accurately being able to swap in and out hot ends is anything but that, but the way this whole setup is laid out makes it where it's somewhat easy to follow. The rack is made of 2 different rows, with each row containing a holding location for 3 hot ends. It's driven up and down on smooth rods and bearings, and it uses a single motor and a belt to do so. All of the electronics for the rack are routed through 2 small cable chains, which feeds power and data to the 6 different hot end stations. These hot ends are held in place with 2 alignment pins and a magnet, and the process of actually manually installing them just has you place them on the magnet in the standoffs on each of its location, and there's a little white LED that lets you know whether you have installed it correctly. While the system itself looks pretty neat, by far the wildest part is actually watching this thing in action, just how quickly that entire rack system moves and how accurately the hot end is able to move from docking location to docking location as it grabs and parks the various hot ends. Moving on towards the back right of the printer, there is a chamber heater that can reach up to 65 Celsius, as well as a filtration system with an exhaust fan. Towards the back left, we have the poop chute and the nozzle wiping station. This uses a combination of 2 levers, with one of them being used to raise a little rubber nozzle wiper, and the other one that pushes 2 metal arms forward that basically pulls away any purged material out the backside of the printer. Other things worth quickly pointing out inside the printer is a camera at the front left, which is used for monitoring prints as well as optional time lapses, 2 long LED light bars at the top to illuminate the printer's work area, and a couple of filament buffers located at the back of the machine. There's also a completely separate inlet back here that's used specifically for loading TPU that I didn't even realize existed until I was grabbing some footage for this video. Interfacing with the printer is done using a 5-inch touchscreen located above the front door. The screen is bright, really responsive, and it's one of the better screens I've used on any of the printers I've tested. By default, the screen is laid up flat against the printer, but you can optionally swivel it upward, which I guess would make sense if you have this printer on the ground or on some sort of really low shelf of a rack. Above the screen is a full-sized USB port for local printing, an automatic vent that can open or close itself depending on what material you're printing with, and on the far top right, there is a large button. I don't fully understand the purpose or point of that button, but in Bambu Lab's wiki, they call it the start pause button. At the back of the machine, we have our power input, our on-off rocker switch, as well as a power safety key. This needs to be installed for the printer to be able to power on, and I believe what I read on Bambu Lab's website was that it was some sort of safety compliance thing, so mine's just been plugged in the entire time I've used this printer. Moving up from there, we have our poop chute as well as the exhaust fan or exhaust vent. These vents are fully automatic, so just like the front top one, depending on the material you're printing with, they will open or close themselves. And if we go up a bit higher, we have our AMS connectivity along with our inlets for our PTFE tube for the left and right hot ends. There is a spool holder on the left side of the machine, which is what I use to load and unload manually all material to the left hot end. If you did want to automate that, they do sell the AMS HT or high temp, which is a single spool AMS, and you can connect that to the left tool head, which would give you the top loading and sort of automatic functionality that you get with the standard AMS system. Unlike their other printers where it's optional, at the time of recording, the H2C is only available in a combo that comes with one of the AMS 2 Pro units. This is Bambu Lab's multicolor or automatic material feeding station. The AMS 2 Pro has been out since the release of the H2D, and it does have some really nice quality of life improvements over the Gen 1 AMS. Some of these include filament drying up to 65 Celsius, easier overall maintenance and repairability, and the use of brushless motors, which gives you faster loading and unloading of filament. I know this was the case at launch, and it still seems to be the case that for the drying functionality, you cannot run it while the machine is running, so it would be something you'd use when the machine is sitting idle to basically help maintain your filament. The reason the H2C comes with the AMS 2 Pro is because it is required to fully use or take advantage of that Vortek system. Since Vortek only occupies the right hot end in the toolhead, every time it goes and swaps a hot end, the filament needs to be unloaded and the filament you want to use next has to be loaded into that new hot end. We'll touch more on this later in the video, but with the left hot end and a single AMS 2 Pro and Vortek, you can print with up to 5 filaments or 5 colors at the same time. If you want to print with all 7 hot ends, that would require a second AMS 2 Pro, so that way you can feed filament to each of the hot ends. Technically, with a hub and more AMS units, I think you can print with up to like 24 colors at the same time, but if you go that route, it sort of defeats the purpose of the H2C and one of its main benefits over the other Bambu Lab printers, which is no more purging outside of, say, the initial calibration or the initial loading of a new filament before starting a print. Typically, I don't like to talk about products that don't exist yet, but Bambu Lab in the FAQ did mention a filament track switcher that would allow you to use 2 AMS 2 Pros to access all 6 Vortek hot ends as well as the single hot end on the left side, which as of right now, the only way to access the hot end on the left side would be either to manually feed it like I'm doing or for it to have its own AMS system, be it the HT or a standard 4-roll AMS. The H2C came packaged really nicely, and setup is really not very different than any other of the Bambu Lab H series or Core XY printers. This largely consists of removing packaging materials, the screws holding the AMS in place inside the machine, as well as the screws holding the bed to the base of the printer for shipping. Then you'll cut a few zip ties, attach the AMS system and the spool holder before you're ready to power on the machine. The first time you turn on the H2C, it walks you through the initial setup and calibration process. This has you select your language and region, optionally connect it to your Wi-Fi network as well as the Bambu Handy app, and then it warns you to make sure that you've actually removed all the screws before it moves the bed to begin the calibration process. This first calibration sequence is a fairly long one, and the screen estimates it at about 26 minutes. This starts by running the printer through a nozzle offset calibration. Then it moves on to the motor noise cancellation. This is something that, if I remember correctly, was introduced in Bambu Lab's A series and then was backwards ported to the X1 Carbon and I think P1S, but it takes your toolhead or your motor and runs it through a sequence of different accelerations and movements to sort of dial in the custom drivers that these ship with and ultimately make the motion as quiet as possible in these printers. Next is input shaping or vibration compensation. And finally is the automatic bed leveling. This runs a really large mesh covering the entire build plate using a load cell located in the toolhead. Given the size of the machine as well as the density of the mesh, this is one of the quicker leveling sequences I've seen on any printers I've previously tested. Once the primary calibration is completed, we need to set up the Vortek hot-end rack. I've used a lot of printers over the past decade or so, but setting this up and just watching it work is something that I found fascinating. It starts by using the toolhead camera to take measurements of the location of the 6 different docks. After that, it verifies the location by using the pre-installed Vortek hot end to go over to each docking spot and load and grab the hot end again. This process is then repeated a second time before it's ready to move on to the next stage. Now it's time to load the hot ends onto the rack. Using the screen, you can switch between rack A or rack B, which raises up one of the racks and drops the other one down out of the way. Then take each of your hot ends and place them on the rack. It took me a couple of tries to figure out exactly how I needed to place these on the racks, but once you figure it out, it's quite simple, and the little white LED that shows up when you've placed the hot end correctly is extremely helpful. Once the racks are completely loaded, you'll click README, which then has the toolhead go around grabbing each of the hot ends to read what the nozzle size is on that hot end, as well as the type of hot end. There is a standard and a high flow variant. Once this completes, the rack is calibrated and ready to rock and roll. The final calibration is for the AMS unit, but luckily this one only takes a couple seconds. One thing I found interesting on this stage was that there's a note telling you to cut your PTFE tube, depending on the location you have it, to shorten it because that will speed up the filament loading and unloading process. Since the filament unloading and loading is the slowest part of the tool changing or hot end swapping process, it makes sense that they would have this. But personally, I like the convenience of having the added length of the tube so I can move the AMS beside the machine or on top of the machine depending on what I'm doing. So for all my testing, I left that Bowden tube the full length of whatever it's shipped with, which I think is maybe 900 millimeters. The final step of the AMS calibration is just to load in a single spool of filament. That way it can go down to the tool head and touch the sensor, and the machine can verify which of the hot ends you have the AMS connected to. With that out of the way, we are finally ready to print. I started off by loading in some VoxelPLA to all 4 lanes of the AMS, as well as into the hot end on the left. I then printed out the pre-sliced color plate that came on the printer. Once it started printing, I was really excited to stand over the machine and watch each of those hot end swaps take place. Really, the main benefit I was excited for with a system like this was getting rid of all of the purging, both for the time involved with purging as well as just having purged material everywhere. But one other big benefit of a system like this is that you are not going to run into any sort of issues with color bleed, which is in a multicolor single hot end setup. Every time you do a filament swap, it has to purge out the old filament, and depending on the color and filament type, if you don't have enough purge, you can actually get color bleed. But in a system like this with dedicated hot ends for filament for each print, that is not going to happen. I was really pleased with the outcome of this test, and it showed me that clearly all of the calibration process and stuff we just went through had gone successfully because colors were exactly where they should be. From here, I moved on to slicing my own files. At the time I began testing the H2C, the printer wasn't actually out, so I was using a beta or pre-release version of Bambu Studio, but since this came out in November now, I transitioned over to whatever the latest Bambu Studio public release is. One big improvement to the slicer that came with the release of the H2D is the addition of the filament saving mode. Since the H2D only has 2 hot ends, you're going to be purging a lot more between filament swaps. So when slicing, it's able to calculate which color or material is used the most in a print, and it will then ask you to load that filament to the other hot end. That way, it's helping to minimize the amount of purging and amount of swapping that you'll need for your print. This serves the purpose of less waste material as well as faster prints, since you're not having to swap and unswap materials nearly as many times. With the H2C, you don't have to worry about the purging aspect, but it still can be used to speed up the printing process by minimizing the amount of swaps needed in a print. One of the main differences when printing with the H2C is that for every print you have a one-click option to choose what nozzle size or what hot end size you want to print with out of the options you have loaded on the Vortek system. In the case of this printer, since I started testing it, the setup I've had is 4.4mm nozzles, 1.2mm nozzle, and 1.6. So if there's a print where I just want finer detail, I can opt to use the 0.2 by just clicking it from the menu. And if there is a part where I just want it to print out quicker and doesn't need to have quite so much detail, I can click on the 0.6 option. Currently, the biggest downside of this is that you cannot mix and match different nozzle diameters within the same print. This is something I became aware of recently when I was testing out a different ToolChanger, and as far as I can tell, it's just a limitation of the slicer, not something that is hardware limited. I reached out to Bambu Lab about this because I have this dream of being able to print with a 0.6 or 0.8 nozzle for my infill, and then say a 0.4 for my outer walls, so that way the part is strong and looks really nice. And they did acknowledge this idea or this function, but I didn't get any sort of information as to whether it's on the roadmap exactly or if it might be coming. As for printing, I went through a wide range of models on the H2C, including everything from just things that I thought would make for a good stress test to actually using the printer for some functional things I needed over the last couple months. As far as overall print quality goes, I was really pleased with the quality that I've been able to get off of this machine. For the hot end swapping, I primarily tested out large amounts of it using PLA, and it handled this beautifully. The most complex model I printed was a bust of Venom, which had a total of 1,163 swaps, and the printer handled it without a single hiccup. Actually, in all of my printing and in all of my testing, the Vortek swapping system never gave me an error or had any sort of issue in grabbing or parking the Vortek hot ends. In addition to the PLA printing, I printed out all parts for my Micron Plus build using a combination of ABS and ASA on the H2C. While these are not multicolor parts, I wanted to use the H2C for just things that I needed, and even though there were lots and lots of small pieces for this, the bed adhesion was fantastic. Not that it is a requirement, but I have really grown to enjoy having access to chamber heaters and printers, especially when I'm printing things that are like ABS and ASA and up. I needed to print out a dust clamp setup for my CNC machine, so I hopped over to Shaper 3D and designed something that would mount onto my Z stepper motor. I then used the 0.6mm nozzle to print it out of PETG, basically just to verify that it actually fit and worked the way I expected. And then once I confirmed that, I swapped over to printing it out of PET CF. This is something I absolutely could have printed out with a 0.4mm nozzle, and typically I would have, but having access to a 0.6mm nozzle at just the click of a button when I go to slice it means that I'm a lot more likely to take advantage of having access to different diameter nozzle sizes. As for the 0.2mm nozzle, this is something that I have never used before. They've existed for a really long time, probably since I started 3D printing or close to it, but I remember a lot of buddies of mine using 0.2mm nozzles and running into issues with clogs and jams, so I always avoided using it until now. For this, I just wanted to run a single print to see how it would go, so I found some small tabletop miniature models and sliced them up and printed them out with the 0.2mm nozzle. The primary issue I ran into was some stringing that was caused by a bit of buildup that formed on the tip of the nozzle. Ultimately, this led to failure on one of the parts, but for the other two parts it completed successfully. It is pretty wild to see how much detail you can actually achieve with such a small nozzle. And I used a silvery gray material that has a bit of a metallic sheen, which makes it hard to pick up all those details on camera, but there is a lot of them. Another thing I wanted to try out with the H2C was printing with some flexible filament. I've printed and made a video on printing flexible filament on the H2D, so I knew that it was capable, but given that it's sort of a different setup, I wasn't exactly sure how to go about printing flexible filament. I was a bit confused by the instructions outlined in the wiki, as well as some of the options or lack of options on the screen. My initial attempt was to print out some printer feet using PEBA or PEBA filament, and that didn't go all that well. I used the same printed top mount setup that I had printed out for the H2D and loaded it into the left toolhead. On the screen, there was only an option for TPU for AMS for the left toolhead, so I selected that to basically trick the machine and then adjusted settings in the slicer to more closely match what I would need to print with PEBA. The parts ended up printing, but there was plenty of stringing, and there was also clear signs of some extrusion issues. At this point, because I wasn't exactly sure what I did wrong or what I was supposed to be doing, I reached out to Bambu Lab for some clarity. And they told me that because the left hot end raises up and down, it's more likely to clog or jam when printing with a flexible filament. So as of right now, they are not recommending using the left toolhead for any flexible other than TPU for AMS, which is a more rigid flexible, and that's why it was there as a menu option. The solution is to use the Vortek side for printing with flexibles without the AMS connected, because the AMS is not compatible with flexibles outside of TPU for AMS because of issues with the elasticity and it leading to clogs or jams. So I loaded up some 95 ATPU directly into one of the Vortek hot ends. This turned out much better. I started off with printing out a ball, and the top looked great, the bottom not so much, which was more a factor of TPU supports bonding or not being close enough in some areas. I decided to follow this up with a model that wouldn't require supports in TPU, and it turned out awesome. There's overhangs on this, and it's sort of a wire management routing organizational thing, and their extrusion spot on, and it's a really solid TPU print. Bambu Lab did let me know they were working on some sort of improvements via firmware that would then allow you to use the left hot end more reliably for printing with flexible filaments, so that way you could dual yield flexibles. By the time of recording and the time of my testing, this has not been possible. One thing I think is important to touch on and address in a video like this is the differences between a system like Vortek with a single toolhead and swappable hot ends versus a more traditional ToolChanger that swaps out the entire toolhead. After my time using both of these systems, I feel like I have a pretty good idea of what the pros and cons are of one over the other. Let's start off with the pros. One of the biggest benefits of a system like the H2C is absolutely convenience. Over the past couple of years, I've really enjoyed using something like the AMS system for its ease of top-loading filament and overall spool management. Sure, there are some limitations, such as odd spool diameters and the occasional cardboard spool that just doesn't play nicely, but for the most part, being able to just pop a spool on the top and know I have access to it from the computer whenever I need it is very nice. Another big convenience that I mentioned just a moment ago is with the hot ends and having access to load and unload different hot ends at just a click of a button, depending on what it is that your goal is and what you're trying to print. Sure, you can absolutely run different hot ends or nozzles on a full ToolChanger, but when it comes time to actually swap them out or replace something that has a clog, I can just about guarantee you're not going to find a faster solution. The final benefit of a system like this is the overall footprint. Sure, the Vortek hot end rack absolutely takes up some space in the machine, but when you compare that to a full-size tool head times 3, 4, 5, 6, however many you've got, it is a fraction of the space needed. And so it means that there is overall footprint of the machine is going to be smaller and you are losing less potential build volume. Now for the cons, with the biggest one being print times. On a traditional ToolChanger, all of your filaments are loaded into each of the toolheads at the start of a print, and they will stay inside of those toolheads for the entirety of the print. That means that anytime you need to swap color or material, the toolhead just needs to park that toolhead, release it, go over to the next tool it wants to grab it, and within a short time span, it is up and printing again. With the H2C and Vortek, this is not the case. During each hot end swap on the H2C, the AMS2 Pro or AMS on top also has to unroll the filament and then roll in the new filament. Granted, the AMS2 Pro is by far the fastest spool swapping system I've ever tested or seen so far, but there's no denying that it does take additional time. With my stock full-length Bowden tube, from the time it stopped printing to begin the swapping process to the time it was actually printing again, I measured right around 30 seconds. Multiplied by a handful of swaps over an entire print, probably not a big deal. But to put things into perspective, for every 100 swaps, this equates to an extra 50 minutes. So if you've got hundreds or thousands of swaps, you can see how that can quickly add up. The other big trade-off comes in the form of filament compatibility. Other than, say, TPU for AMS, you are not going to be able to take advantage of TPU filament with the Vortek system. Depending on your specific needs, like if you just need to print a single color TPU occasionally, or maybe dual if they get that unlocked, then that's fine. But if you're printing heavily with flexible filaments, then simply this system is just not a good solution for you. Additionally, the AMS2 Pro is not compatible with abrasive filaments. If you need to use an abrasive material in a print, you can load it on the left hot end. You can even automate that process using one of the AMS HTs. But if you need to print with multiple abrasive filaments in a print, like many of them, you just simply cannot do it with the AMS and Vortek. I'm sure there are some other pros and cons that I'm maybe not bringing up or not thinking of, but based on my time testing out the different technologies, these are really the primary standout things to me. So what are my thoughts on the H2C based on my time with it so far? Overall, I've really enjoyed using this printer over the last few months. I never did a review video of the previous H2D, but that printer has been sitting beside me basically since launch, and the H2C in a lot of ways just feels like a supercharged H2D. It's faster because I'm no longer purging material, and as much as I'd come to terms with the reality of having to have waste and purge material using a setup like this sort of as a trade-off for convenience, I definitely don't miss having to waste a bunch of material on prints and manage all sorts of a mess caused by the purging coming off of the printer. Having one-click access to different nozzle diameters has me rethinking a lot of the ways that I'm slicing up different models, and similar to how I feel the AMS was and is a game changer for overall filament and spool management, the Vortek system is doing a very similar thing, but for the hot end. The only hiccups I had were some errors at the beginning of a print where the camera couldn't see the stripe marker located on the front right area of the build plate. I reached out about this during my testing to see if we could figure out what was going on, and ultimately we discovered that it was due to my bright studio light that was casting a glare on that surface. A bit of a larger issue I ran into during my testing is an issue with the auxiliary fan. At some point during my testing, I noticed that the fan, when it kicked on, just sounded a lot noisier, and it sounded like the fan blades were almost rubbing or scraping on a surface as they were spinning. When I contacted Bambu Lab, they said that they had been made aware of this issue and had corrected it, but it did affect a handful of units, with my machine being one of those. They did end up sending out a replacement fan really quickly, but due to this fan issue sort of coming and going, as well as the complicated steps required to remove panels to access the fan, this isn't something that I've jumped in and done just yet. Having easy access to just about all parts on the Bambu Lab printers via their web store is something that I have always loved. However, from past experience, the actual process of repairing or swapping out parts, depending on what they are, can be quite daunting. While I haven't had any issues with the Vortek system or Vortek hot ends, this is only after a few months of testing, and inevitably, like everything else, after a certain amount of time, something will come up that will require a bit of maintenance or even repair. Given that the Vortek system is out in the open and relatively easily accessible, I feel like this is something that maybe Bambu Lab did consider, but until I reach that point, or people begin to reach that point where we need to do more maintenance or repair, it's hard to say what that process is actually going to be looking like. For as much as I love building my own machines and modding them and having full access to them, I've come to terms that this is the exact opposite of the Bambu Lab experience, and I am completely fine with that. These are the printers that I lean on the most when I need to get a project done, or if I just want to throw the parts at the machine and feel confident that it's going to get the job done. Are they perfect? No, but what machine is? Everything comes with some form of a trade-off, and it's hard to deny that Bambu Lab has raised the bar as well as lowered the entry point for many people that just want to print. While I realize that this system won't be for everyone depending on your specific needs and application, it checks a lot of boxes, and I'm excited to see how the Vortek system continues to evolve and develop. At the time of recording, the printer along with a single AMS2 Pro combo is priced at $2,399 US, which is well above what I would consider a hobbyist level machine. But when comparing it to other enterprise printers, it is extremely competitive and punches well above its weight class. And that has been the H2C and Vortek. I hope that you enjoyed this video and that you have a much better idea of what the system is, how it works, and what you can expect from it. There is and was an absolute ton to cover, but I try to be as thorough as possible and hopefully answer the majority of questions. If you do have any additional ones, let me know in the comments down below. As always, if I don't know the answer, I have no problem reaching out directly to Bambu Lab to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!